Hi everyone, I am Bindeshwar from Post Network Academy, and in this video you will know about random variable and distribution function. So consider a random experiment in which you are tossing 3 coins. So if you are tossing 3 coins, you will get the following outcomes: either 3 heads, 2 heads and 1 tail, 1 head, 1 tail and again 1 head, 1 tail and 2 heads, 1 head and 2 tails, 1 tail, head and 1 tail, 2 tails and 1 head, or 3 tails, where S is sample space, H is occurrence of head and T is occurrence of tail. Now let us define a random variable. So a random variable is a function from the sample space S into the set of real numbers. You can see here X is defined as from sample space to set of real numbers, where Rx is the range of X. Now see that here we will define a random variable, where random variable is defined as number of heads xs, where s is an event in the sample space S. So S is an event in sample space S. So see that what will happen again. So here see that here number of heads are 3. So I have written 3. Number of heads 2. Number of heads 2 again. Number of heads 2 again. Here number of heads 1. Here number of head is 1. Here number of head is 1, and which number of head is 0. And because I have defined random variable is number of heads, that's why I am writing. You can also define a random variable that number of tails. So first of all you have to define a random variable. So I have defined random variable as number of heads. So what will you get? You will get either 0 number of heads or 1 or 2. 0, 1, 2 and 3, which is Rx. So you can say that a random variable is used to quantify sample space. Now let us see probability distribution. So here probability mass function f, which is a function from Rx to real number, defined by fx is equal to probability of x is equal to an event, and this is a probability mass function of x. Fx is probability mass function of x. Now let us understand it by an example. Thereafter you will understand. So see that here F0, if I am putting, because you can, if you remember that we have Rx is equal to 0, 1, 2 and 3, right? So if x is equal to 0, it means there are no heads, and that case was we had only one sample, and this is the 3 tails. If you talk about one head, so there are three samples. So this one, and this one. So out of 3 heads, out of 8 you have 3 sample points in which you have one head. Again F2 means Px is equal to 2, and it means that there are 2 heads. So this point, and this point. So Px is equal to 2 is equal to 3 upon 8. Again this one where 3 heads, so you have only one element. So this is also 1 upon 8. So see that here, again understand probability mass function, which is from Rx to R. So Fx is defined from Rx to R, where Fx is equal to P, x is equal to, which is an element of S. So actually this is not element of S, this is from Rx. So x may be 0 or 1 or 2 or 3, and for that one you will have some probability. So x is equal to 0, that means there would not be any head, that is 1 upon 8. One head, 3 upon 8. 2 heads, again 3 upon 8. And 3 heads, only one element in sample space. So probability mass function of random variable x is distributed, you can see here. Now let us understand the property of probability mass function. So probability mass function has 2 properties. The first one, it is greater than 0, and the second one, if you add all probabilities, that would be equal to 1. So first property you can easily observe that all probabilities are greater than 0, and see that if you add all the probabilities, so 1 upon 8 upon 3 upon 8 plus 3 upon 8 plus 1 upon 8, that would be equal to 1. So it holds 2 properties. If these 2 properties, probability mass function does not hold, so it is not probability mass function. So this was about random variable. Hope you have understood. In upcoming videos I will explain about probability density functions and probability mass functions. So thank you for watching this video.